Continuing with section 1.8. So section 1.8, we are going to look at more examples and more definitions. So if we have a matrix A like this, that the first row is 1A, 0, 1, what is A? Can be any real number. Then the transformation from R2 to R2 defined by T of x is equal to AX is called a shear transformation. So what is a shear transformation? It's, in this case, the points along a certain line or axis stay where they are, but the transformation, it acts on all the other points and moves them in a certain direction, parallel or covering at a certain distance as well, and they move parallel to the fixed axis. So let's look at this example. Let A, example 3, A is the matrix 1, 3, 0, 1, and we define the transformation T of x is equal to AX. So find the images of the corners of the square defined by the lines x is equal to 0, y is equal to 0, x is equal to 2, and y is equal to 2. And then also we have to draw the square and its image. So down here, I drew the square, and then the points of the square are, I gave them names. So O is the point at the origin. The coordinates are 0, 0. The point A has coordinates 2, 0. The point B has coordinates 2, 2. And the point C has coordinates 0, 2. So these are basically, we can talk these at the endpoints of the vectors. So I am giving each vector a name. So at the point O, the vector will be 0, 0, because those are the coordinates of the point. We just put them in as a vector. And then I call the vector U. And when you find T of U, we end up getting the same thing, 0, 0. So it means the point, the O or the origin stays where it is. At the point A, let's call the vector A. So A vector is 2, 0. And then when I plug it into the transformation, I get back 2, 0, because I multiply the vector by the matrix. So if you multiply, you will see that 2 times 1 is 2, plus 3 times 0 is 0, so we get a 2 here. And then 0 times 2 is 0, plus 1 times 0 is 0, so we get 0 in the second place. So A point stays fixed. So all the points actually on the x-axis now will stay fixed. So what about point B? Well, I call the vector associated with B is B. So in other words, this vector is B. And then we apply the transformation to B, and we get 8, 2. So it means the B point is shifted to the point 8, 2. And then same thing with the point C. The vector, I am calling it the vector C, which is the vector 0, 2. And then when we apply the transformation, this gets shifted to 6, 2. So down here, I have now the square, which was at, 2 by 2 square. And now everything on the x-axis remained the same. So it just stayed here. But the point C got shifted to 6, 2. And the point B got shifted to 8, 2. So height remains the same, but the points have shifted. So now when I join, my square now looks like a rectangle or a parallelogram. So this is how this shear transformation works. Next example, it says let T be a transformation from Rn to Rm, and let it be linear. So we already know that this is a linear transformation. And suppose that T of U is equal to V. So U is some vector which is being mapped onto the vector V. Show that T of minus U is equal to minus V. So what it is saying is that if u gets mapped to v, then negative u gets mapped to negative v. So how can we show that? Well, because t is linear, so t of negative u can be written as negative of du, or negative 1 times du, and I can do it because of this linearity. So if we have, remember the linearity property says this, that t of cx will be equal to c of times t of x. So t of negative u, so negative u can be thought of as negative 1 into u. So the negative 1 can come out because of linearity. So we get negative of negative 1 times t of u, but t of u is v. So we end up getting t of negative u is equal to negative v. And that's what we had to prove. Okay, the next one is okay, so next example number 5. Define a transformation t of x is equal to ax plus b. Show that it is not linear transformation when b is not equal to 0. And this is called an affine transformation. Okay, these have important applications in computer science. Now I have done this I have shown the solution using this like a combined or a the combined equation for linearity. But if you want, you can do it separately using two results or two equations. One is to show that t of x plus y is equal to t of x plus t of y. So if you can show this, and if you can show t of rx is equal to r of tx, r times t of x. Then it means the transformation is linear. And if one of the condition fails, then we don't need to check the other condition. We can just say it is not linear. So here when I'm discussing the two cases, first is the case when b is equal to 0. So when b is equal to 0, the transformation looks like t of x is equal to just a times x. And here is the work. If you are doing it using the first condition, you will have, so you can take u, v, or you can take x, y, it's your choice. So if you use x, y, then you will say this is equal to a times x plus y, which means ax plus ay, which means, well, ax is what? Ax is the t of x and plus t of y. So yes, first one is true. Now the second one, t of rx. So this will be equal to a times rx, but which will be equal to a times rx. So r gets multiplied with a first, and then the matrix gets multiplied with the vector. But with the same as we multiply the a matrix from the left with the scalar, because the scalar can be on the left or the right, but if you have matrices, you cannot move them. So this is equal to r times t of x. So this is also satisfied. So yes, this is linear. In the same way, now I have to show that this is not linear. Okay, so we can again do the separately. So you can do t of x plus y. So that will be now a times x plus y plus b. which is going to give you ax plus ay plus b. Now note, we want to if we can show that this is equal to t of x plus t of y, then one of the statement of linearity will hold, and then we can check the other one. But if we cannot show this thing equal to tx plus ty, then we can just stop there and say that this is not linear. So if you notice here, for this to be t of x, it should look like ax plus b. So if I have ax plus b plus ay plus b, right? And so because we don't have that, so you can see already we are in trouble, so we cannot put it back. So what I do here, I stop here and I now pick the other side. So I say now, so this is as simplified as it gets. So now what if I check this, which I wanted to get? So this gives me ax plus b plus ay plus b. So now note here, these two are not same, not linear.